Welcome, aspiring innovators. Have you ever dreamt of creating your own robots, but felt overwhelmed by the perceived complexity or cost? Well, imagine turning a corner of your home into a personal innovation hub. Today, we're going to demystify the process and show you exactly how to build your very own functional mini robotics lab, perfect for beginners and seasoned makers alike. You don't need a massive budget or a dedicated workshop, just a passion for learning and a bit of guidance. In this comprehensive guide, we'll walk you through setting up your workspace, identifying essential tools, selecting core electronic and mechanical components, diving into the world of programming, and finally, embarking on your exciting first projects. So, grab a notepad, hit that subscribe button, and let's start building your future in robotics. First things first, your workspace. You need a dedicated, clean, and well-lit area. This doesn't have to be a sprawling desk, even a small table can suffice. Ensure you have ample power outlets and good ventilation, especially if you plan on soldering. Organization is key in any lab. Invest in small bins, drawers, and labels to keep your components sorted. Nothing is more frustrating than searching for a tiny resistor. Now, for essential tools, a basic screwdriver set, pliers, wire cutters, and wire strippers are non-negotiable. A multimeter is crucial for troubleshooting circuits. For electronics work, a soldering iron with appropriate safety gear like a stand, sponge, safety glasses, and ideally a fume extractor, is vital. Don't forget basic safety measures. Keep a fire extinguisher nearby, always wear eye protection, and be mindful of hot tools and sharp objects. A tidy and safe workspace ensures smooth and enjoyable prototyping. Now for the heart of your lab, the core components. You'll need a microcontroller, the brawn of your robots. For beginners, an Arduino Uno or an ESP32 is an excellent starting point due to their vibrant communities and extensive resources. For more complex projects requiring more processing power and operating systems, a Raspberry Pi is a fantastic choice. Next, consider sensors. Ultrasonic sensors for distance detection, IR sensors for line following, and photoresistors for light detection are great for learning how robots perceive their environment. For movement, you'll need actuators, servo motors for precise angular control, DC motors for continuous rotation, and stepper motors for accurate positioning. Don't forget the fundamental building blocks like breadboards, jumper wires, resistors, capacitors, and LEDs. Finally, for the mechanical side, a few basic wheels, a simple chassis, standoffs, nuts, and bolts will allow you to assemble your creations. With your hardware sorted, it's time to bring your robots to life through software and programming. The most common integrated development environments, IDEs, are the Arduino IDE for Arduino boards, and for Raspberry Pi, you might use Thonny or Visual Studio Code. When it comes to programming languages, C++ is predominantly used for Arduino, while Python is a popular and beginner-friendly choice for Raspberry Pi projects. Start with fundamental programming concepts: variables, loops, conditional statements, if, else, and functions. Understanding these basics will empower you to write almost any program. Leverage libraries. These are pre-written codes that simplify complex tasks, making your coding journey much smoother. Remember, programming is an iterative process. Write a bit of code, upload it, test it, debug it, and repeat. Numerous online tutorials, documentation, and forums are invaluable resources for learning and troubleshooting. Finally, let's talk about turning theory into practice, your first projects and future expansion. Start small and simple. A classic, hello world, of robotics is blinking an LED. Then, move on to controlling a servo motor, reading sensor data, or building a basic obstacle-avoiding robot. Websites like Instructables, Hackster.io, and various YouTube channels offer endless project ideas with detailed instructions. As you gain confidence, you can expand your lab. Consider acquiring a 3D printer for custom parts, an oscilloscope for advanced circuit analysis, or more specialized sensors and actuators. Engage with the robotics community. Online forums, local maker meetups, and open-source projects are fantastic ways to share knowledge, get help, and find inspiration. Robotics is a journey of continuous learning and experimentation. Embrace failures as learning opportunities, keep exploring, and most importantly, have fun creating. Your mini robotics lab is more than just a collection of tools, it's a launchpad for your imagination. Start building today.